Hello everyone, today I'll be teaching you how to integrate, uh, let's say it's a double integral. So since we are dealing with a double integral, what we're going to do is we integrate, let's say, inward to outward. So first we're going to integrate it using dx here, and then after integrating using dx, we need to integrate it using dy. So that is what we should keep in mind when dealing with a double integrals. First is what we're gonna do is that we're gonna integrate the e using dx. Since we're using dx, the y here, should be considered as a constant. Thus, we could please refer to my old video so that you would understand how we integrate this. The formula should be 1 over, since the y is a constant, we would do this as 1 over y, since it has 1 here, 1 over y, e raised to x over y dy. So dy y cubed over 0. And then we just need to substitute the y cubed in the 0. So substitution, integral of 1, 0. Let's just simplify this first. Try to simplify this first. So that should equal to y. Then let's substitute it. Take reminders that since it is dx, we should only substitute the x, not the y, since the y is the constant. And x, y cubed over y minus y e 0 over y dy. Integral of 1 over 0, since y cubed here would be 2, cancel out. 0 should be cancelled out. 0, any number raised to 0 would be 1. So that's just 1 here. 1 times y should equal to just y. So our simplified is y multiplied by y squared minus y dy. Let's just delete some things in order to make space. Sorry about that. So let's move it here. Since we're here now, we need to do it using dy. Since it is y here, we need to integrate it via y basis. Understand? Here, another y. So we're going to do is that since the y here could just be used, could just be solved using power rule, we need to focus on the y and the e raised to y squared here more. So let's just solve it first, and then we would move on to dy here. Solving here at y raised to y squared. We need to let u be y squared. The derivative of y squared du would be 2y dy, not dx. My bad. So 2y cancel out. 2y. There we go. So sorry. Integral of 1 over 0 2y. The du here, the dy is equals to the du here. So since it is equals to the du here, we should do 1/2 1 0 and y e raised to u, since we let uy squared, and then du over y. We just took out the constant here and place it there, and then here minus, and here minus, just the power rule, which is y squared over 2 1 0. So let's just focus here for a second, and then we just do we just cancel here, cancel, and we are left with 1/2 integral of e u du minus y squared over 2 1 over 0. EU, the integral of EU is just EU. So 1/2 integral of EU is e raised to u, yeah, EU is y squared, e y squared 1 0 y squared all over 2 0 to 1. So that's it. We're just gonna, how about this? We're just gonna substitute it. Let's try. So 1/2 e 1 squared minus e 0 equals to y, 1 squared all over, say, 2 minus 0 squared all over 2. 0 squared all over 2 would be cancelled out. Here would result to 1. And here 1/2, I guess. So 1/2. And here would just stay the same. E. Wait, let us erase this first. After that, since we canceled it out, 1/2 should equal to e, 1/2 multiplied by e minus 1 minus 1/2 here. Simplify it even further, we just need to distribute this here. So e over 2 minus 1/2 minus 1/2 would be -1. E all over 2 -1. And You could just you could leave it here as the answer. Just add plus c, then this would be your answer. Or you could just factor it out. So 1/2, oh sorry, I need to change the color white. 1/2 e minus 2. Because 1/2 multiplied by 2 is equals to 1. So, I mean, we're lacking. Oh, no. We shouldn't add plus c because it's a double integral. Sorry about that. So, this should be your final answer. This could be your final answer, but it usually depends on the professor whether they'll accept it or not. So, that's all about it. See ya and good luck. Bye bye.